This is 5.2/5.3 part 3. So if you did not watch the first two videos for this section, please go back and do so, because it basically explains some of the rules of the definite integral, and it also talks about Riemann sums. So let's continue on with example number 4. Evaluate or simplify the following. And we see that we don't have any movement because the upper and lower limit are the same. So when that happens, I really can't compute the area underneath the curve because I don't have an interval to do that. So the answer to this is 0, because that's what the area is, 0. Okay, again, the upper and lower limits were the same. Okay, let's look at B. The upper and lower limits are different, and I'm going from 1 to 4, and I have a constant, which is 5. So the rule says for a constant, I take the constant and then I'm multiplying that by b minus a. So the constant again is 5. The b value is the upper limit, which is 4, and the lower limit is the a value, which is 1. So I take 5 times 3, which equals 15. Okay, so that's the area for this one. All right, let's look at this next one. If I look at C, my upper and lower limit are in reverse order, so I have to fix this. In order to fix this, I need to have 3 as the b value, or the upper limit, and I need to have 0 as the lower limit. So when that happens, you have to put a negative sign out front when you have to fix it, and then you would integrate 2x dx on those intervals. Now, how do I do that? Well, you have to integrate the 2x first. So I'm going to take 2 times x is to the first power, so I'm going to add 1 there, over 1 plus 1. So this becomes 2 times x squared over 2. 2's cancel out, and I'm left with a value of x squared. Now I'm going to evaluate that from 0 to 3. And you're going to learn more about this in the next section. But what you do is you do b first. So I'm going to take 3 squared, because the function or the integral is x squared, so 3 squared. And then I'm going to subtract a from it, which is 0 squared. Okay? When I do that, I get 3 squared, which is 9, minus 0, which is just 9. And again, the next section will address this. So if I look at D, my first integral is going from -1 to 5, f of x dx, and the next one is going from 7 to 5. And we're subtracting the 2. So I have a little bit of work to do, because again, the second one has a problem because the upper limit is smaller than the lower limit, so I have to fix that. So first things first, I'm going to leave the first one alone because it's going from -1 to 5, f of x dx. Then I have this negative here. I'm going to put another negative. And I'm going to fix this by making the upper integral, instead of 5, put the 7 on top and the 5 below. Again, you have to have the upper limit bigger than the lower limit. So if it's in reverse order, what you have to do is take and put a negative out front. Okay? So now that I have these two added together, because a negative and negative is going to make a positive right here. Whoops, let me fix that. I'm going to have a positive in between the two, and now I can put them together. So I'm going to integrate from -1 to 7 of f of x dx. Okay, so that had a little bit of work to do. So now let's look at the theorem. If f of x is continuous on the interval from a to b, then f of x is interchangeable, or integral, sorry, on a to b. I don't know why I keep on doing that. Meaning that if it's continuous, then you definitely can take the integral from those values, upper limit b, lower limit a. It exists. Okay, so how do I figure out if something exists or not? You have to look at the intervals. So for the first one, we're going from 1 to 2. And I know that because I see the upper limit is 2 and the lower limit's 1. And if I plug that into our function, I'm okay. Because 1 over 1 equals 1. That's okay. That doesn't zero out the denominator or do anything weird. So the second one, 1 over 2, that also is okay. So again, neither one of these zero out the denominator, and we can conclude that they are, the domain is continuous from 1 to 2. So does it exist? Yes. So if it is continuous, then it exists. So let's look at the second one. Now I'm going from -1 to 2. Again, I'm going to check. Okay, so from -1 to 2, check it. So -1 over 1, okay. Or I have that backwards, but it should be +1 over -1, but it's still okay. All right. So checking out the next value. So 1 over 0, not okay. And I don't even have to check anymore because I just have one spot. 1 over 0, where it's the domain is not constant, right? It's not continuous. So it's discontinuous when x equals 0. Okay, so does it exist? No. And once again, it's because when x equals 0, the function is discontinuous. All right, so that is the end of 5.2/5.3.